graph the equation r equals 6 sine theta. To graph this equation, what we need to do is to obtain a table that contains the values of theta from 0 to 2 pi and its corresponding r values. Then we plot it on a polar axis. So we have our table beautifully drawn here. So these are the theta values, and then the r values will be here. Now we will start from 0 and then start in order of pi over 6 up to 2 pi, but 2 pi is the same as 0 degrees. So now if you put 0 into this equation, it becomes r equals 6 sine 0, and that will give us 6. Then r equals 6 sine pi over 6, that is equal to 3. R equals 6 sine pi over 3, that's equal to 3 root 3. So it's 3 root 3. Then r equals 6 sine pi over 2, that's equal to 6. So if you keep on filling up, then here will give us 3 root 3. Then 5 pi on 6 will give us 3. Then pi is 0. Then here is minus 3. Here is minus 3 root 3. Here is minus 6. Then here is minus 3 root 3. Minus 3. And then we'll go back to 2 pi. And 2 pi is the same as 0. So the next thing is to represent these angles on the polar axis. So we start from 0 in the anti-clockwise direction. The next one is pi on 6, which is this. The next one is pi on 3. And the next one is pi on 2. And the next one is 2 pi on 3. Then 5 pi on 6. The next one is pi, 7 pi on 6. Then here is 4 pi on 3. And here is 3 pi on 2. Then here is 5 pi on 3. Then here is 11 pi on 2. So we keep adding pi on 6 to the subsequent angles to get this. So now that we've gotten this, we can now go ahead and then plot it. So the origin here is 0. Then you see that if we look through the r values, we have r equals 3. We also have r equals 3 root 3. 3 root 3. Then we also have r equals 6. And then as far as we can go, that is the highest values we can get. So here is 0. Then here is 3. Then here is, so let me write them on the pi over. So here's 3. And here's 3 root 3. And this place is 6. So if we had any other value inside there, then that value would have come here. So the down here to be 3 minus 3. Then here is minus 3 root 3. So let's go ahead and do the plot. So 0 and 6. Here is 0. And then 6. This is 6. So 0 and 6 is this one. And apart from here, pi over 6 and 3. So pi over 6. This one is 3. So pi over 6 and 3. Then pi over 3 and 3 root 3. It's here. Then pi over 2 and 6. Pi over 2 and 6 is here. Then here is 2 pi over 3 and 3 root 3. 2 pi over 3 and then 3 root 3. So 3 root 3 is the side. Then apart from that, we also have 5 pi over 6 and 3. 5 pi over 6 and 3. It's here. And then we have pi. Pi is 0. So here is pi. 0 here. Then 7 pi over 6 is minus 3. 7 pi over 6 minus 3. It's here. Then 4 pi over 3 and minus 3 root 3. So here's 4 pi over 3 minus 3 root 3 is this one. Then here's 3 pi over 2 and minus 6. 3 pi over 2 minus 6 is here. Then 5 pi over 3 and minus 3 root 3 is this one. And then 11 pi over 2 and minus 3. 11 pi over 2 and then minus 3. It's here. So you can see that if we are supposed to join them, it's going to be a circle that has center 3, 0. So we are going to get the circle. So you can see that this is a circle that has center 0, 3 and then radius 3. So we can do the same thing at the bottom here. So you can see that this is a graph of a circle with center 0, 3 and radius 3. Now, you can see that when you look at this graph, you see that there is a symmetry about the polar axis. And then you can also see that there is also a symmetry about the line pi over 2. And there's also symmetry about the pole. Now, there are ways of checking if a polar equation is having symmetry about any of this. Either the polar axis is symmetrical about the polar axis, or it is symmetrical about the line pi over 2, or it is also symmetrical about the line or the pole. Unfortunately, in as much as these equations can sometimes predict that there will be symmetry or there will be no symmetry, there are some of the graphs for which the equation fails, yet you see symmetry in those graphs. Now let's start with the equation. So we're given r equals 6 sine theta. Now to check whether the graph is symmetrical about the polar axis, you need to do if r of minus theta is equal to r of theta, then the graph is symmetrical about the polar axis. So in this case, let's find r of minus theta. It's equal to 6 sine minus theta. But I know that sine minus a is equal to minus sine a. And therefore, this is equal to this is equal to minus 6 sine theta. And this is equal to, and this is not equal to r of theta. So it means that this graph fails for the test for the polar axis. And what it means is that the graph is not symmetrical about the polar axis. But you see that though the equation proves that this graph should not be symmetrical about the polar axis, our drawing shows that the graph is symmetrical about the polar axis. So you see, this is an instance where the equation fails, yet the graph proves that this is symmetrical. So this equation is an odd one. It does not obey this rule in this sense. Let's try for the line pi over 2. To test whether it is symmetrical about the line pi over 2, we need to replace pi by pi minus theta. So r is equal to, we are using pi minus theta, so r is equal to 6 sine into bracket pi minus theta. So r is equal to 6, then we have sine pi cos theta, then minus cos pi sine theta. and this is equal to sine pi is 0, so all of this becomes 0. Cos pi is minus 1, so minus minus 1 is 1. So r is equal to 6 sine theta. So you see that in terms of the line pi over 2, this equation passes, even though it fails for the test for the polar axis. It passes for the test pi over 2. And you can see that this circle, even though it has not been drawn to scale, but it is symmetrical about this line, which is pi over 2. This is symmetrical about that line. So you can see the axis of symmetry here. Now let's test for the last one, which is the pole, and that is this point. And to test whether the graph is symmetrical about the pole, we need to use theta equals theta plus pi. So r is equal to 6 sine into bracket theta plus pi. So this is equal to 6. Then sine theta cos pi plus cos theta sine pi. Now, what is sine pi? Sine pi is 0, so all of this will go to 0. But cos pi is minus 1, so this becomes equals minus 6 sine theta. And you see that minus 6 sine theta is not equal to r of theta. And therefore, when we test for symmetry about the pole, it is not supposed to be symmetric. Nonetheless, our diagram shows that the graph is symmetric about the poles. So it also fails. Though the equation fails for symmetry about the poles, the actual diagram passes for symmetry about the poles.